4.2 notes in Algebra 1 are about transformations. Transformations are movements of geometric figures in the coordinate plane. Geometric figures basically just means shapes. They can be any sort of shapes, triangles, rectangles, anything. And we're just going to take those shapes and move them around the coordinate plane in specific ways. There are 4 types of transformations that we're going to talk about in this class: rotations, translations, dilations, and reflections. Rotations, we kind of know what they look like, and for the test you just need to be able to identify a picture that matches a rotation. So a rotation would be if I took a triangle and I kind of turned it around, so now the triangle looks like that. Another word for a rotation would be like a spin. Notice in a rotation the 2 shapes are the same size. They're just being turned around. Translations. Translations are like a slide. So I'm going to take my triangle and I'm not going to turn it around. I'm just going to move it somewhere else. Another word for a translation is a slide. And again, notice that the shapes are the same size. A dilation is where we take our triangle and we either make it bigger or we make it smaller. With a dilation, they have the same basic shape to it, but one's bigger and one's smaller. Another word for a dilation would be a shrink or a stretch. The last type of transformation we're going to talk about is a reflection, where I would have a triangle and I'd have some sort of line, and I'm going to reflect it over, so now it's upside down on the other side of that line. Another word for reflection would be a flip. Reflections are also the same size in the original and in the new image. Take a minute and pause the video and see if you can use your notes that you just took and decide which type of transformation does each diagram represent. One is going to be rotation, one's transformation, one's dilation, and one's reflection. Pause the video and see if you can figure out which one is which. The first picture is a dilation. The one with the triangles is a reflection. The smiley faces are a rotation. And the stars are a translation. For the last thing in this section, we're going to take figures and either move them or reflect them or rotate them. And what we're going to do this is make a table. The table is going to have room for us to write the coordinates of the original and of the new ordered pairs for each point. Take a minute and copy down both the table and the graph. Pause the video, write it down, and then we'll go over what to do together. What we're going to do on a problem like this is start by figuring out what's the ordered pair for the original points. So in my table, I have a place to write the ordered pair for point A, point B, and point C. Point A has coordinates 1, 2, 3, comma 1, 2, 3, 4, 5, 6. The original ordered pair is at 3, comma 6. The original ordered pair for point B is at 2, comma 2. And the original ordered pair for C is at 1, 2, 3, 4, 5, 6, 7, comma 1, 2. We are supposed to reflect this triangle over the y-axis. So we have to be careful. The horizontal one, that one's the x-axis. The one they want us to reflect it over is the y-axis. So we're going to take all of these points and reflect them over. If I took point A and reflected it over, I'm not going to change how high up it goes, but I'm going to change, instead of going 1, 2, 3 units to the right, I need to go 1, 2, 3 units to the left. So the new point A, which is going to be A with a little line next to it, that one has coordinates -3, comma 1, 2, 3, 4, 5, 6. We'll do the same thing for point B. For point B, when we reflect it over, it's still going to have the same height, but instead of going 1, 2 units to the right, we're going to go 1, 2 units to the left. The new point B ends up right there, and it has coordinates -2, comma 2. When we reflect point C over, again, we're not going to change the up and down, but instead of going 1, 2, 3, 4, 5, 6, 7 units to the right, we're going to go 1, 2, 3, 4, 5, 6, 7 units to the left. So if we went 7 to the units to the left, that's -7, comma 2. Then connect the dots to make our new triangle. As we look at the two triangles, they have the same exact size and the same exact shape. It's just a reflection. It's been flipped over the y-axis. And notice every single time what changed. Every single time, the first number changed from being positive to being negative. And the second number stayed the same. That's always going to happen when you flip over the y-axis. It'll be slightly different if you go over the x-axis. The homework in section 4.2 has a part that's out of the textbook on page 200 and also some pages in our packet. There are 3 pages that are a 4.2 worksheet you need to complete.